guys, it's Ajad. Welcome back to my YouTube channel. Alright, so in the past, I made videos surrounding Amazon, kind of going over my experiences, the interview process, as well as a sample problem. I've even done that with one of my friends who interned at Google, going over the interview process as well as a sample problem. And so one pretty big company that I haven't really addressed is Facebook. And so although I don't really have experience working at Facebook, in this video, I'm going to be presenting you guys a pretty popular LeetCode question that has been asked before in like technical coding interviews at companies like Facebook. It's a pretty popular problem called subarrays with some K. And so helping me out in this video, I have one of my friends, Neil. And so let's get to it.
Alright, Sajad, so I know that you're always interviewing people on your channel, but today I want to switch it up and interview you. So I'm going to be asking you a special LeetCode question that has been used a lot in the past by companies such as Facebook. So how does that sound? Are you ready?
Well, you know me, I'm always ready. Let's just get to it.
Awesome. So the problem that I'm going to have you work on today, you're given two inputs. You're given an array of integer numbers and an integer K. And your task is to find the number of subarrays in the original input array such that the sum of the subarrays equals K. Does that sort of make sense? Or do you need any further clarifications?
Okay, so just like sounding it out, it's basically given an array, go through, find subarrays that sum up to K, return the count. Is that right?
That's correct. Yeah.
Is it possible I could see some examples of sample inputs, outputs?
Oh yeah, of course. Here is our first example. In this example, we have a numbers array of 1, 3. We have K equals 2. We can clearly see that there are two subarrays whose sum equals 2. There are the first two elements and the second two elements. Giving another example, we have this array. The first two elements sum to 3, so that would be one subarray. The last element, 3, by itself is a subarray. That would also be a valid candidate solution. All in all, there are two.
Gotcha. So, just to clarify further, a subarray is essentially defined as any part of the array, or like obviously subarray, that length is greater than or equal to 1. Is that correct?
That's correct. And the biggest thing is that a subarray has to be contiguous, so you can't skip over elements.
Oh, okay, I see. But anyways, I guess my preliminary approach to this problem, like the brute force approach, is iterating through the given array, having a sub-iteration, like variables I, and within that variable j. Given those said indexes, I'm gonna have to compute the sum within those. The second example, you have like 1, 2, and 3. I'll set I to be starting at 1, j to be starting at 2. Check if 1 plus 2 equals 3, and yes, we'll add that to our count. I'll move over and check if 1 plus 2 plus 3 equals 3, and obviously then in that case, I wouldn't add it.
What do you think the time and space complexity of this brute force algorithm would be?
The initial nature, we have nested loops, so that's going to be at least n squared. There's another loop inside of that, actually, when we're going from like I to j. Worst case, we have to go through the length of the whole thing. It's going to be O of n cubed.
Right. What's the space complexity of the algorithm?
So actually in this case, we're not using any extra space. We're just using a lot of iterations. So the space complexity is actually going to be O of 1.
So would you like to go about implementing this code?
Yeah, sure. I'll go ahead and get started. So creating this method, I'll just say, I'm probably going to first need an overall counting variable. I'll set that to be total. That is essentially going to be the return variable. And then I'm going to have to iterate through the array at the beginning. So this is just going to be for I in range len nums. Within that, so there's a sub iteration that starts at I plus 1, j in range plus 1, comma len nums.
So John, for the outer loop, maybe you should recheck your bounds.
I have it going to len nums. So I see what you're saying, because if we have it at len nums minus 1, which is what the len goes to, I plus 1, that's going to be, we're going to get an out of bounds issue. Do actually is set this to range len nums minus 1. And within this, now I'm actually going to get inner sum within this sub loop. So I'm going to actually do this should account for all the cases that I'm dealing with, and then ultimately I'll just return total.
So should we run your function with a couple examples?
Yeah, sure. I think we can just use the examples you gave. Nems equal to 1 comma 2 comma 3, k equal to 3, print num sub nums comma k. Let's see what the output is. It's 1. I think I see where the problem is. So I have j starting from I plus 1, but I see the problem is because subarrays could consist of only one element, like that is a valid subarray. I actually need to have it starting just at I. This should be accurate, I believe. Okay, perfect. 2. Obviously, like, I know that I have to optimize this. O of n cube is probably not acceptable by any means.
Let's think for a moment and see how you can eliminate the need for the third inner loop. Perhaps there's some room for optimization in that loop.
This is actually something I've seen before with Fibonacci, how we are able to store the value of computed sums such that we're able to reference it in O of 1 time, but build it as we're going through. Before we head into this nested loop, I'll actually pre-process the given array such that I'm able to access the inner sum at an O of 1 capacity. So I'm guessing you'd probably ask me what the time complexity would be. That would actually be O of n squared, because it would essentially be O of n squared plus n, which is really just n squared.
So let's go about implementing that optimization.
I'm gonna create a sum array. First element to be 0, because we haven't reached any elements till that point. Iterate through the elements of nums. At the index of that, I'm gonna append it to the sum array. Set inner sum to be equal to sum r j plus 1 minus sum r of I. Is the difference between those values, which is the sum between I to j. Alright, so I'm going to print out with the example 1, 2, 3 with k being 3. We'll run that. And we got 2. So that's great.
Alright, Sajjad, so there's actually one more optimization that we can make to this code to take us down from O of n squared time complexity to O of n. I'll give you a hint. We're going to be making use of maps and hash maps. You could think of any potential use of this data structure in the code for O of n optimization.
We actually don't care about what indexes we're at. Like, for example, I use a sum array, but who really cares that where everything is? We've had it map to something completely different. You mentioned the use of the mapping data structure, which is actually a really valuable one, taking a lot of operations down to O of 1. As we're iterating through the given array, if we've reached a sum that we've had before in relation to k, so probably like that total minus k at that point, that is something we add to the counter. But I mean, if it's just our first round going through it, we probably just want to append it to the dictionary.
Interesting. So let's try coding it out.
What I'm gonna need, obviously, still that total variable to ultimately return, and then a dictionary visited. For arrays that only consist of one element, if we reach k on the first thing, we're going to need to check that against something. 0 is a valid sum. Whether we've iterated through the array or not, we have some 0. So what I'm actually going to do is set visited 0 equal to 1, because we visited it before. We're going to have to keep a sum variable going on to check up against. And so I'm going to go through for num in nums. First thing I got to do is inner sum plus equals num. Okay, so I'm gonna check if inner sum minus k is within our given array. I'm actually gonna add that frequency to our end return value, the total. Now I'm gonna check if just inner sum is within it, because we want to check for that frequency. Visited inner sum equals 1. Else, so we have visited it before, now we just have to increment the frequency that we visited it. Now this is actually the case where I prefer Java, because we could use the get or default method and we could make this one line of code, and then return total.
Awesome, let's test it out.
Yeah, sure. So our target value for this given input and output is 2. So I'll run this. And we got 2.
Awesome.
Yeah.
The code works and it's an O of n. Perfect. So this was a very tough problem that not many of us at Facebook got in our first try. So it was really nice working with you today on this problem. brings back a lot of memories for me. Do you have any questions for me about this problem or otherwise in the interview process?
So when am I gonna get my offer and what's my salary gonna be?
Well, that's about all I have for this video. I really hope that you guys enjoyed it, and if you did, be sure to let me know by hitting that thumbs up button. And lastly, just as always, for more content, don't forget to subscribe, and I'll see you all in the next video.